Have you ever seen an idea this crazy, turning two ordinary plates into a homemade antenna? It sounds hard to believe, so today I have to try it and see. And my goal is to turn these two plates into the signal receiving part of a homemade antenna. So the first step is pretty straightforward. I'll drill the two holes I've already marked on the handles of these plates to get them ready for assembly. To keep the assembly neat and make it easier to mount onto the antenna base, I'll bend the handles of these two plates to about a 90-degree angle, so everything sits cleaner and is less awkward to work with. In my hand, here are two bolts and two nuts, and they'll act as the middle piece, connecting the signal receiving part to the antenna wire. For the signal to transfer efficiently from the receiving part to the wire, it's better not to make a sloppy connection. So here I'll use two terminals of this electrical connector block to make the link solid and stable. To save some time, I've already prepared an antenna base with simulated coil section and a plug mounted on it. This setup works efficiently, pulls and signal really well, and it's simple enough that you can look at it and easily copy the idea if you want to build one yourself. And do you know why a simple combination of a magnet, some aluminum foil, and wire, nothing fancy at all, can act like an inductor and actually help the antenna receive signal better? Basically, that simulated coil creates a more stable magnetic field, which helps guide and hold the signal, reducing losses. So the signal entering the wire ends up cleaner and stronger than a simple direct connection. Next, I've got a length of coaxial cable to carry the signal from this homemade antenna to the TV. So the first thing I'll do is terminate one end of the cable with a straight F connector and a 90-degree F connector. If you don't want to get an electric shock, make sure to wrap electrical tape carefully around any exposed connections. A few extra turns won't hurt, and it keeps things a lot safer and more comfortable to use later on. As for the other end of this cable, I'll attach a female power style plug so it can connect directly to the antenna unit. This way it's cleaner, more secure, and a lot easier to plug in or remove when needed. For anyone who's not familiar with it, this here is a female power plug. It looks like a regular household electrical part, but in this setup, I'm just using it as a simple, easy to find connector for the antenna. So at this point, everything is basically finished. From the build to the wiring, it's all set up nice and clean. Now there's no point talking anymore. I'll hook this homemade antenna up to the TV, and let's see how the signal actually comes through, and whether it lives up to the expectations. Take a look here. Right now the TV is still showing no signal at all before I connect a homemade antenna, so we can clearly see the difference. As soon as it's connected, the signal comes in right away, which is pretty impressive. But to know whether it stays stable over time, we just need to watch it for a bit longer and the answer will show itself. Up to this point, nothing negative has shown up at all. The signal has stayed stable. So I'll unplug the connection and plug it back in once more, see how it responds. I can say that we've succeeded, not in some big dramatic way, but in that very familiar sense you get when you spend time in a workshop, where an idea that sounded a little crazy at first actually ends up working just the way you hoped it would. Starting with two ordinary plates, things that no one would normally associate with antennas or signal reception, and step by step, through testing, assembling, and cleaning things up, they've turned into a signal receiving part that genuinely does its job. What I enjoy most about projects like this isn't how powerful the final result is or how many channels it can pull in, but the process of understanding why it works. Seeing how small changes in wiring, positioning, or adding a simple simulated coil can make a noticeable difference in signal quality is a good reminder of why I got into DIY in the first place. It's about curiosity experimenting, and that quiet satisfaction when everyday objects turn into something useful. Of course, this homemade antenna isn't meant to compete with professional systems or expensive equipment, but what it gives back is something just as valuable: real hands-on experience and a sense of control. Once you understand the basic principles, you can tweak it, improve it, or rebuild it in your own way. And that freedom is really the best part of making things yourself. So if you watched this far, the only thing I'd say is don't be afraid to try. And don't shy away from ideas that sound a bit unconventional at first. Sometimes the simplest materials end up teaching you the most. For now, I'll let this antenna keep running for a while longer. And if anything interesting shows up, I'll be sure to share it with you in the next video.